I'm going to solve part A of this hungry mouse problem here. So in part A, they want to know the average velocity of the mouse during its motion. Okay, so we have a mouse. Let's draw a little mouse here. And the mouse is heading towards a block of cheese. So I'll draw a block of cheese. All right. Okay, mice love Swiss cheese. All right, so the mouse is traveling to the east, so that tells us that this direction is east, and that's probably going to be important when we look at vector quantities, where we do have to include the direction. Okay, and we want to know the average velocity of the mouse during this motion. Well, this distance here is given as 30 meters from the mouse to the cheese, but the mouse doesn't travel at the same rate during that 30 meters. For the first 15 meters, it travels at 0.75 meters per second, and for the second 15 meters, it travels at 1.5 meters per second. Okay, so we're going to need the formula for average velocity. If they ask you to calculate something and you don't have the formula written down, you should always write it down. So average velocity, remember, is displacement divided by time. And since displacement is a vector, we know that average velocity is also a vector, so we're going to need to include a direction with our final answer. Okay, so now I can just write this in variable form. I'll say that v bar, the bar is for average, is delta x over delta t. Okay. And now I need to figure out what delta x and delta t are, and I have a little bit of a problem. I know delta x, the mouse started 0, ended up at 30 meters, so delta x is just 30 meters minus 0 meters, but I don't know delta t. How long did it take him to get from here to there? But I do know that the first 15 meters he traveled at one rate, and the second 15 meters he traveled at another rate, so I can just use the simple velocity equals distance over time formula, since I have a constant velocity for each of those two travel segments there. Okay, so I'm going to use this formula here. V equals d over t. Rate equals distance over time. So the first time, I'll call it t1. So I solve this for time. That's going to be the distance d1 over v1. Okay, so the first distance is 15 meters, and he's traveling at 0.75 meters per second. And when you do that on the calculator, you end up getting 20 seconds. So it took him 20 seconds to go the first 15 meters. And then the second time, t2, so it's d2 over v2, well, the second distance is also 15 meters. Except now he was traveling at 1.5 meters per second. And when you do that on the calculator, you end up getting 10 seconds. So he sped up for that second 15 meters. I guess maybe he could see the cheese and he got excited. He decided to speed up, travel a little faster. Okay, so now we can do this. Delta x we know is 30 meters. And delta t, well, the whole thing took 30 seconds. So that's 1 meter per second, except remember they want average velocity. So if I want to write this as a vector, average velocity with a little vector symbol would be 1 meter per second east. You need to include the direction since they're asking for average velocity.